We're going to build a little bit more comfort by looking at how to simplify compositions, and this is building towards finding derivatives. So let's start by trying to simplify the secant of arctangent of 1. So the main idea here to keep in your mind is that the arctangent of 1, the inverse tangent of 1, is specifying an angle. This angle is going to satisfy that tangent of the angle is equal to 1, and the angle is going to live between negative pi over 2 and pi over 2. Okay, so what we're actually asking for is secant of this angle theta. Okay. So this composition says what's secant of theta, where theta is the angle, so that tangent of theta is 1. One approach that can be really helpful for working this out is to build what's called a reference triangle for this angle theta. So what we're going to do is build a right triangle where one of the angles is theta. Now, if we look at this triangle, tangent of theta is going to need to be equal to 1. So tangent is the opposite side over the adjacent side. We need that the ratio of the opposite over the adjacent, which is tangent of theta, is equal to 1. Okay. So one fast way of making this happen is just setting these guys equal to each other. Let's set them both equal to 1. Now, because it's a right triangle, we can use the Pythagorean theorem to fill in the remaining side. So we'll take 1 squared plus 1 squared to get the square of the hypotenuse. So our hypotenuse is square root of 2. Okay, now we are looking for secant of theta. This is 1 over cosine of theta, or the hypotenuse over the adjacent side. And if we look at our triangle, we can see that the hypotenuse has length square root of 2, and the adjacent side has length 1. So this is going to be square root of 2 over 1, or square root of 2. So we can simplify secant of inverse tangent of 1 down to just being square root of 2. This has the advantage that we don't need to actually calculate inverse tangent of 1 in order to do the simplification. Let's try the same technique out in the most general case. We're going to simplify secant of inverse tangent of x. Okay. So let's do the same sort of rewriting. Inverse tangent of x is going to be outputting angles theta where theta's between negative pi over 2 and pi over 2. Okay, so we know that tangent of theta is equal to x, and we want to know what secant of theta is equal to. So basically what I like to do is think of replacing tangent inverse of x with what its output is going to be, which is an angle theta. Okay. Again, we can build a right triangle, a reference triangle for this angle theta. We know that the tangent of theta, which is the ratio of the opposite over the adjacent side, needs to be equal to x. And one fast way to make this happen is to make the opposite side length x and the adjacent side length 1. Okay. Again, by Pythagorean theorem, we can find our missing hypotenuse. It's going to be square root of 1 plus x squared. And then secant of theta, which is secant of the inverse tangent of x, is going to be the hypotenuse over the adjacent side, and we see it simplifies just down to square root of 1 plus x squared. Okay, let's try another example. We're going to simplify cosine of inverse sine of x. So we're going to think of inverse sine of x. The outputs of this function are angles. So let's call theta the angle produced by the inverse sine of x. Okay. This means that sine of theta is going to be equal to x. And remember where the outputs live, the range of inverse sine of x is going to be negative pi over 2 to pi over 2. Okay. All right, so we can rephrase our problem as looking for cosine of theta if we know that sine of theta is equal to x. So what we're going to do is build a reference triangle for sine theta equals x. And we will find our missing side to tell us what cosine of theta is going to be. So we want a right triangle where one of our angles is theta. And so sine of theta can be given as the ratio of the opposite over the hypotenuse side length. And we know that this ratio needs to boil down to be x. So one way to make this happen is to make the opposite side length x and the hypotenuse side length 1. Okay, so this is going to be x over 1. Great, and so we have 2 sides out of 3 for this triangle. We can use the Pythagorean theorem to find the missing one. We're going to take the square root of the hypotenuse squared minus our side length squared. So we get the square root of 1 minus x squared. All right. Then cosine of theta, which remember is cosine of the inverse sine of x, is going to be equal to the adjacent side, square root of 1 minus x squared, over our hypotenuse, which is 1. So we end up that this simplifies down to the square root of 1 minus x squared. Notice cosine of theta, if theta is between negative pi over 2 and pi over 2, this has positive outputs, which we see in our answer here, that all of these outputs are going to be non-negative.